Today I'm going to be walking you through the Organic Names and Structures lab. So this lab is pretty easy. You're basically going to be given a bunch of either the names or the condensed formulas, and then you're going to have to give me the formula and the structure. So I'm going to do one or two on each page with you, or probably one on each page. If you need help with these, you just go back to my previous videos on how to name alkanes, how to name alkenes, how to name alkynes, and then how to name branch chain isomers. So that way you can rewatch those and then relearn how to do those, but I'm not going to explain everything from scratch because I've already done this in the past. So let's do one. So right here we have 2,2-dimethylhexane, right? So what you're going to do is you're going to always work backwards. So a hexane, now in order to do this, you're going to want to have table P and Q out. So P is just the prefixes, tells you how many there are, and Q gives you a little bit of information about alkanes, alkenes, alkynes. And so hex means 6, and so I'm going to put 6 in a row, all with single bonds. Always start with single bonds, even if it said hexene or hexine. I'm just going to start with singles to make it easier. Then I'm going to number it. Left to right or right to left doesn't matter. Or I should say, left to right and right to left doesn't matter when you're drawing the compound. If you're given the structure, then it does matter. So be aware of that. So now that I have it numbered, it's going to be 2, well, I put it here. So we'll do 2,3-dimethyl, right? So that means on carbon 2, there's a methyl. So a methyl is a branch of 1. It could be up or down, doesn't matter. And then on carbon 3, there's a methyl. Up or down doesn't matter. I chose down and then up just for spacing. If you wrote them both up or both down or up down or down up, it doesn't make any bit of difference. Then we're going to add your H's in, making sure every carbon has 4 bonds. And there's the whole structure. Now, in terms of the formula, this is why we do this. Count it. In other words, hexane means you have 6 in a row, but you also have 2 more methyl groups. So this is really C8H18 when you count it up. So be aware of that. Don't just go off the hexane part. Every time you add a branch, those branches are going to add more carbons and more hydrogens. And then the condensed formula is going to look like this. Carbon 1 only has 3 H's, so it's CH3. Carbon 2 has 1 H directly connected, so it's CH, and then in parentheses, forgot the H. And then in parentheses, CH3 for this branch. Carbon 3 is a CH, and then the same thing, another parentheses, CH3. Carbon 4 is a CH2, carbon 5, and carbon 6, CH3. And that's all you're doing. So that is the alkanes. So now we'll go do the alkenes. Let's pick one. So we'll do one that's reversed of what we've done before. So I'm not going to do these hard looking ones. They're not actually that hard. But we'll go back and do this one because one of these are pretty important. So we start with, I'm going to number these. You don't have to. This is carbon 1. That's carbon 2. It's carbon 3. Carbon 4. This is a branch, so I don't number that. Carbon 5. Carbon 6. So carbon 1 is a carbon with 3 H's. Carbon 2 has 1 H. Carbon 3 has 1 H. Carbon 4 has 1 H and a CH2, CH3 on it. That's how I did that. And then carbon 5 has 2 H's. And carbon 6 has 3 H's. So we'll number them. Now, I'm numbering them first because I already know what's going to happen. You wouldn't actually want to do this yet. You would want to double check the molecule to make sure that there are no missing bonds. Because if you notice between carbons 2 and 3, there's definitely a missing bond. In other words, carbon 2 only has 3 bonds. Carbon 3 only has 3 bonds. So what we're going to have to do to make this right is put another bond in between carbon 2 and 3. That's where the double bond goes, in order to make each of these carbons have 4 bonds. So be aware of that. When you do these types of problems, you have to look for the essentially the lack of bonds in order to figure out where to put the double or triple bonds. So that's why I wanted to do these. These tend to be a little bit harder, just because of that one aspect. Now, once we're done, we count up to do our formula. So there's 1, 2, 3, 4, 5, 6 carbons, 7, 8. So this is C8H, and if we count out our H's, there should be 16. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 H's. And then the name, well, 6 in a row is going to be hexene. The fact that the double bond is between carbons 2 and 3 means it's 2-hexene. And then there's a branch of 2 carbons long on carbon 4. So 4-ethyl 2-hexene. So that is the name on that one. All right, so those are, again, not that hard, but you have to be a little bit more careful when you get these because the bonds are kind of, basically the double and triple bonds are hidden in there. Let's go to the next one. So let's do another one. I guess I can do, I'll do the hard one, the heptatriene. Everyone hates this one. So think of it this way. Well, I'll just set you up on this one. It's called a triine. So what that means is that there are 3 triple bonds, and here's where you find them. So when you do this formula, you're going to have to count out the number of H's because it's not going to fit with the general formula because this thing's going to have very little H's. So I'm going to let you try that. I guess I'll do this first one here. So again, let's number these. Carbon 1, carbon 2, carbon 3. That's a branch. 4, 5, 6. I'm just numbering them so that when I refer to which carbon has the proper number of hydrogen, it makes it a little bit easier to follow, but you don't have to do that. So carbon 1 only has 1 H. I'll just put it up. Carbon 2 has no H's. Carbon 3 has an H and a CH3. Carbon 4 has 2 H's. Carbon 5 has 2 H's, and carbon 6 has 3 H's. Now I'm going to go through and scan because there's clearly a lack of bonds here, right? In other words, this carbon has 4 bonds, so it's good. This next one, 4 bonds, fine. This next one, 4 bonds, good. This next one, 4 bonds, 4 bonds. This carbon only has 2, and this carbon only has 2. So I know this is an alkyne, so that means there's a triple bond here. So the triple bond has to be right there because that will bring this carbon up to 1, 2, 3, 4, and then this carbon will go up to 1, 2, 3, 4. Now when I number this, I start numbering on the left because I want to be as close to the triple bond as possible. So you only need to number that far, but I'll number the whole thing. And then let's count it out. So this is going to be 6 carbons in a methyl, so it's C7H12. There should be 12 H's when you count that out. Now the last part, we have to name it. 7 carbons in a row makes it, or 6 carbons in a row makes it a hexyne. The fact that it's between carbons 1 and 2, it's a 1-hexyne. And the fact that there's a methyl group on carbon 3, methyl 1-hexyne. So that's the last one of the alkynes that I'm going to do. Now we're going to move on to the isomers. So I'm not going to do the isomers with you. If you go back to your notes on drawing isomers, I think I actually do the 5 isomer one in your notes. So look that up, use it as an example, and do the 3 isomer one, or draw 3 isomers of C5H12. I think I do the 3 isomers of C5H12. I do one of these in your notes. So you're going to just do those in your notes, and that's all for this video because now I'm gonna break the video up into a couple sections, otherwise it would be too long.